Okay, so let us start. So elastic load balances. Our next topic is elastic load balances. One thing I missed to talk when we discussed VPC. Let me ask you one question. Okay, and that we will discuss when we learn load balances. We will discuss that. Let's forget it. So you know that choosing the subnet also means choosing the availability zone because each subnet falls in a single availability zone. So if you select your EC2 machine in a go in a particular subnet, you are also choosing which availability zone your machine is actually going to be physically located. Two things happens, right? So what I'm trying to say is you can choose what is going to be your availability zone of your machines. Okay, great. Next topic is elastic load balances. So if you have any questions, you can put the questions in the chat. At the end, we will discuss if you have any questions. Otherwise, put all your questions in the chat. Yeah. So the elastic load balances. Think about the situation. I mean, think about you have a website, or think about Flipkart.com, or think about any web application which your company have. This web application should be Aravind. Yes, we can have multiple subnet in same availability zone. Each subnet will fall under one particular availability zone. That is the thing. In a availability zone, there can be any number of subnets. That's fine. Yeah. All right. So think about this situation. Your traffic is growing. You have a web application like Flipkart or like Google or like your WordPress website. You have a web application, and there are lots of users using the application, and the chances are very less that a single machine can serve all the people. Let's say maybe there are thousand simultaneous users browsing for your website. Maybe a single AC2 machine Apache running inside it can actually serve all thousand people. But if the traffic is growing, let's say it become 2000 or 3000, the traffic when it grows, then this single machine become incapable of handling all the traffic coming to it. So in that case, what you generally need to do is you need to have maybe one more machine that is nothing but the same as the other machine. Let's say you have set up WordPress and you have the web application inside this machine. The second machine is a clone of the other machine. Maybe what you can do is you can take an AMI from this machine. From this AMI you can create the second machine, then both machine will look alike. Now this together, this machine can handle the traffic. The traffic is 4000 users. Together this machine can handle the traffic, and now the traffic is growing again. Now the traffic is 6000 users browsing your website. From the same AMI you can create one more machine. So like that, in real-time cases there would be multiple machines serving the traffic. In case of Google, maybe there are hundreds of machines serving the traffic globally to the users. So if there are too many machines, how do you make sure that all machines are getting equal traffic? Let's say total you have 6000 people browsing your website basil.com. You want 2000 people to be sent to this machine, 2000 people to be sent to this machine, 2000 people to be sent to this machine. That is how the load balancing will happen. I mean, each machine should get equal load, then the load is balanced. How you will make sure that all machines are getting equal load? What you can generally do is put a load balancer. Think about Apache as a proxy. So just this load will act like a proxy. It is called elastic load balancer. This is given to you as a service by AWS. You can create a elastic load balancer in AWS. Then your website, you will point your website into this load balancer apart than pointing it to the actual uh, actual EC2 machine. So anybody who browse for your website basil.com, they will first connect to the load balancer. Load balancer will send the first user to this machine, second user to this machine, third user to this machine, fourth user to the first machine again. Like that, it will make sure that all machine in the backend will get the equal load. So when I browse for basil.com, I hit load balancer on port 80, of course. My browser hit load balancer on port 80. Then the load balancer will connect to the backend machines on port 80 and fetch the pages from the backend machine and then serve it to me on my browser. So it is the responsibility of this load balancer to make sure that all backend machines are getting equal load. So, so what happened for your DNS? What will happen in your DNS system? You already have a DNS system. Basil.com points to the IP address of your EC2 machine. You added a record there pointing basil.com to the IP address of your EC2 machine. In your EC2 machine, you have Apache and WordPress. You need to change this setting, of course, because right now anybody who browse for basil.com globally, they always directly connect to your EC2 machine. That's not what you want. You want the people, your customers, to be connecting to the load balancer instead of connecting to the machine directly. So what you should do, of course, you need to point basil.com to the load balancer IP. The load balancer will be a public machine. It will have a public IP. It will also have a DNS name. It will have a public IP as well as a DNS name. Generally, you will not point your website to the IP of load balancer. Normally, what you do is you point your website to the DNS name of the load balancer. I mean, actually, I will tell you the reason. Uh, when you create a load balancer in AWS, AWS would not give you an IP, they will give you a DNS name. It is the name you want your to point your website into in your authoritative name service, Route 53 or whatever. You need to go into your authoritative name server. You need to remove this entry that points basil.com to the EC2 machine directly. Then you need to add a new record. It is not a record, this is called CNAME record, to point basil.com to the name of the load balancer, something like your load balancer dot elb dot amazon aws.com, something. Whenever I created load balancer, AWS give me a name for this load balancer, a DNS name. To that DNS name, I will point my website to www.basil.com. I will point my website to that particular name. So what is CNAME? Basically, CNAME is nothing but instead of IP, you want your website to be pointing to a name. So how your website can point to a name? Actually, CNAME record you specify basil.com is an alias for the other DNS name. So if somebody requests for basil.com IP address from the authoritative name server, they are going to get the IP address of this DNS name, whichever your load balancer DNS name is. That name's IP address is what you are going to get. Your customers are going to get, and they will automatically then connect to the load balancer when they want to fetch the page. I will talk about it in a bit, right? Let's not maybe. Yes, Raj. One second. All right. Okay, so I told you what the load balancer do. Load balancer will balance the load across multiple backend machine, provided that you pointed your website at the load balancer. Then whatever request coming from world, different browsers, different customers of you, whatever request coming from the world, it will not directly hit you, any of your EC2 machine. It will connect to your load balancer, and it is the load balancer which will route the traffic to the backend machines and make sure that each machines are getting equal load. Okay, one more thing your load balancer can perform. Yeah, actually I turned off my Wi-Fi by mistake.
Basil,
Yeah, now it's you can hear me, right? Actually I got disconnected. Yeah, so what I'm trying to say is, you have the load balancer which takes care of load balancing. It will make sure that every backend machines are getting equal load. Okay, fine.
Basil,
Yes, Devabrat,
we are unable to hear you actually.
now you can hear me, right?
Now I can, but just now.
You missed it. Yeah, yeah, I will repeat. Actually, I by accident I turned off my Wi-Fi, so and the connection got lost. Yeah, so I will repeat. What I was trying to say is, when you create a load balancer, it balances the load across the backend machine. We already discussed that. The load balancer will make sure that whatever request coming to the load balancer is spread across multiple backend machines. All backend machine will get equal load. If there are 1,000 people browsing, first machine will get 333 or 334. The other machine get 333. So all machines will get equal load. That's what the load balancer will make sure. Okay, now let me ask you one question. Let's say for some reason this machine went down. Maybe there's a problem with AWS data center. They got a power shutdown. Their UPS got some complaint, and my machine got turned off automatically. And this machine is completely down now. So any request, any users who is browsing my website, if they are redirected to this machine, then they will get a timeout because this machine is down. So what I want my load balancer also to perform is continuously do some health checking on the backend machines. Load balancer will continuously check the backend machine to make sure that they are healthy. If any machines are found not healthy, load balancer will not send request to that machine anymore. Let's say every 5 minutes or every 30 seconds, a load balancer would check each backend machine, and when it checked this particular backend machine, it found that it is not getting any response from the backend machine. Maybe what this load balancer will do is it will send an HTTP request to the backend machine, and it will wait for a response. So every 30 seconds it will perform this check. Every 30 seconds it will send an HTTP request to the backend machine and wait for the response. If no response are coming from the backend machine, then the load balancer will believe that okay, this machine is not working. The machine is not responding to HTTP. So it is not a good idea to send the usage to that machine. What load balancer will do is it will cut the connection with that backend. Then automatically the people who is browsing your website would be redirected to the healthy machines. Only the healthy machines will get traffic now, not the machine which is down. So basically your website would be available to people who are browsing, no matter if one or two of the machines are down. People will be automatically redirected to the healthy machines. So this kind of check which a load balancer would perform are called health check. You can configure the health check. Maybe it is nothing but an HTTP request which is sent to backend, and load balancer will wait for the response. And if it does not get any response, then the machine is marked as down. That's what the load balancer will do. Can you also how we can do clustering for load balancers? Yes, we will. Just remind me once after we are done with today's class, Sunil. Okay. Now let's create a load balancer now. So the first thing I will do is I will create a machine, a EC2 machine. I will install Apache in the machine. Then I will add that machine behind a load balancer which I am going to create. So let's take yesterday's VPC, the Jan2 VPC that we have created yesterday. So click on EC2. Click on instances on the left side. You have my machine, on machine here. I don't want that. I'm going to create a new machine. Select Jan2 as the VPC that we have created yesterday, and first machine I'm going to create in the public subnet. I will create one more machine which I will create in the private subnet. So the existing keeper December 4, yeah, it should be. So I created a machine. This machine I created in public subnet, so I am going to name it public subnet machine something. Right. I'm going to create one more machine in private subnet. I think when I created the public machine, I forgot to give it a public IP. That's okay. I will give it an elastic IP. Right. So private machine, I don't need a public IP. So let's leave it. So I created two machines. One is created in public subnet. One is created in private subnet. Private subnet machine. Give it some name. Okay. I created two machines. This is the machine which is in public subnet. This is the machine which is in private subnet. Both are in same VPC Jan2. Right. Okay. What key for private instance? Why didn't you use? Actually, Aravind, it is a new machine that I created, right? So it doesn't have any key. The public machine doesn't have any keys. Okay. So first thing, I will log into this public machine. Actually, I forgot to give a public IP to my public machine. What I would do is I will create a elastic IP. I already have one elastic IP that. Oh, actually, you have created NAT gateway yesterday, right? Please delete it. It is chargeable. Yesterday you have created an elastic IP. I mean a NAT gateway. If you did, delete it. It is chargeable. I forgot it yesterday. So yeah. After you are done with your testing, delete the NAT gateway. Right? Elastic IP is also costly. When you created the NAT gateway, you created an elastic IP also. This IP also you need to release. So first you need to wait for the NAT gateway to be deleted. Once it is deleted, you need to come here, then remove this elastic IP also. Or you can go to the EC2 page. From the EC2 page also you can see your elastic IP. But I cannot release it right now. It would give me an error. Once this NAT is deleted, then I can remove this elastic IP. So what I would do is for my public machine, I want an elastic IP. So click on allocate new address. I am allocating a new public IP, a new elastic IP. And this new IP I am going to attach to my public machine. Select associate option, then select your public machine. Click on associate button. That's it. Hmm. Okay, so that's it. You attach this IP address to your EC2 machine, the public machine. Now let me log into the public machine and I will install Apache in that machine. Log into the machine. Now install Apache. Install Apache. So Apache has a default page, right? I mean that we will use for testing. In your case, when you do the project, you need to set up a WordPress website instead of sample Apache page. Yeah, that project I will talk about it later. So I installed Apache. Now I am going to open the port 80 on this machine. HTTP. Open port 80. Okay, cool. So now I can browse for this public IP in my browser. I can see the Apache sample page. So always remember I am browsing the IP address directly. So how does my browser work? I am opening from my Mac. I open my browser, browse the IP address of my EC2 machine. So it will directly connect to my EC2 machine, and from the EC2 machine, Apache is running inside the EC2 machine, which would give me this page, and that is how I got this page displayed in my browser. Okay, great. Now what I am going to do is, now what I am going to do is I am putting both this machine, the public subnet machine as well as the private subnet machine, putting both machine behind a load balancer which I am creating. First, I will create a load balancer. Then I will attach these machines, the private machine as well as public machine. Remember, this public machine is running Apache. In this machine, I am not installing anything. Let's not worry about this machine. Of course, I can install Apache, but let's leave it. So now I am going to create a load balancer. You will find three options under the load balancing. You would find two options. One is target groups and one is load balancers. Target group is nothing but the list of machines which are going to be attached with the load balancer. Right? In the target group, you would mention how many machine you want to add or which machine to be taken part of the load balancer. So you create the group of the machine. Then this target group you would attach with the load balancer. Then automatically all backend machines part of that group would be attached with the load balancer. The health check settings, all these things you can specify when you create the target groups. So first I will create a target group. Click on create target group. It will ask you in which VPC the target group will be created. You can select your Jan2 VPC. Target group name, you can give it any name, maybe TG WordPress. So my plan is I want to create a group that contains my WordPress machines, and this WordPress machine I want to attach to my load balancer. That is what my requirement is. That's what I'm going to do. So I gave it a name TGWP, the target group name. What protocol? Basically Apache. All my WordPress machines are running Apache, and the machine will be contacted by load balancer through HTTP. That's what it means. I have these many machines in the target group. Later, this target group is going to be attached with the load balancer. So which port this group of machine would listen on? It's port 80 through HTTP. That's what I am selecting here. Which port the load balancer will connect on the backend machines? It's port 80. Protocol is HTTP. It's instance. Actually, these are nothing but instances, EC2 instances. Which VPC I am creating this target group? That means this group of machine in which VPC they are going to be placed in. They are going to be in Jan2 VPC. That's the VPC that we have created yesterday. Then I told you the health check settings over here. The load balancer want to make sure that all these backend machines are up and running. If any of the backend machines are down, then load balancer immediately want to disconnect that machine from the load balancer, so that people who browse for your website, they will get the page only from the healthy machines. They it want to immediately disconnect the unhealthy machines. So you want to perform some health checks. So that health check settings you can specify here. Through HTTP, the load balancer will connect to the backend machines. And this page it will try to access. And if it is able to access that page, load balancer will automatically mark the machine as healthy. That's what this health checking means. If you click on the advanced button, you will get more options like healthy threshold. Basically, 5 times the machine should pass the health check, then only the machine will be marked as healthy. HTTP request would be sent to the backend machine by load balancer. The machine is responding. It will not immediately mark the machine as healthy. It will perform the check again after some time. Actually, after 30 seconds is what you mentioned here by interval. So after 30 seconds, it would again try to connect to the backend machine through HTTP. Again, it got the successful response. So it will repeat 5 times, and in the fifth attempt also the backend machine is responding fine. Then the machine will be marked as healthy. That is the threshold that you put here, healthy threshold. Unhealthy threshold. Now you know what is meant by unhealthy threshold. 2 consecutive times the backend machine is not responding to the load balancer, then the backend machine would be marked as down. That is what mean by 2 here. Timeout, right? Of course, you know what is mean by timeout. The load balancer tried to connect to the backend machine, but the backend machine is not responding within 5 seconds. Then it is a timeout. Interval every 30 seconds, the check would be performed. Success code. So this is the response which load balancer would expect from the backend machine when it send the HTTP request. Whenever you send the HTTP request, the backend machine would respond with a code that should be 200. So all these settings you can specify in the target group. So once you created the target group, you can create the load balancer and you can specify you want load balancer to be using this particular target group. And you select your target group, you click on targets. Here you can see the targets, the list of targets. If you want to add any machines, you can add it here. Click on the targets, then click on edit button. This is where you can actually add your machines. So I have 2 EC2 instances inside my VPC Jan2. It would automatically show up. What I can do is I can select the machines, then click on add to register, then automatically both machines would be added into this target group. Now click on save button. That's it. Now I added both machines in the target group. Now if you click on the target tab, you can see both of your EC2 machines, the public subnet machine, private subnet machine. This machine is running Apache. This machine is not running any softwares. Right. All right, fine. So now I am going to create a load balancer and using this particular target group. That means these two backend machines would be added to the load balancer. So click on load balancer, click on create load balancer. Then I want HTTP load balancer. My purpose is whoever browsing my website, I want to serve them using my load balancer. So I want to create a HTTP load balancer. The click on create button. It will ask you for a name, maybe LBWP, LB WordPress, or any name I can give. Here I can choose, should my load balancer face the internet? What would be the answer? Let's say my purpose is basil.com. I have a internet website. I want my customers. It is a global website. Anybody who want to browse basil.com, I want them to be pointing to my load balancer. So should my load balancer face the internet or not is what I need to select here. Of course, it should be internet facing, right? So I want my load balancer to be facing the internet. So I check this box, internet facing. IP address type IPv4. Yeah, that's true. Listeners, which port or which protocol the load balancer would listen on? Of course, your load balancer is facing the internet. This side of your load balancer is the internet. This side of your load balancer is your backend machines. And it is the load balancer which faces the internet. From internet, people browse for basil.com. They will hit the load balancer on port 80. So the load balancer must be listening on port 80. Then you need to add a listener port as port 80. So you want your elastic load balancer that you are creating in AWS to be listening on port 80 for HTTP. So what you would do is, over here you select HTTP as the protocol, 80 as the port. If you want to add multiple listeners, you can do that. Let's say you want to add Tomcat also. You can select HTTP port is equal to 8080. So like that, single load balancer can actually listen for multiple ports. That's fine. So in my case, let's remove everything. I want my load balancer to be pointing only one single port, 80. Okay. Then over here, I need to select my VPC. Make sure that you are selecting the same VPC as your target group. Don't miss that part. It should be the same security group as your, it should be the same VPC as your target group. So as soon as you select the VPC, it would show you what subnets you have, in which availability zone the subnets are located. So you can actually choose, should your load balancer be load balancing across multiple availability zones? You can choose here. Got it? So I'm choosing whichever subnet my machines are spread across. Okay, fine. Tag, if I want to add, I can add any tag. Let's say type is equal to WordPress. I can add some tag, which is nothing but the identifier of my load balancer. Click on next. Configure security, forget it. Click on next. You need to create a security group. Just like your EC2 machine, your load balancer also can have a security group, right? So I'm going to create a security group for my load balancer. And of course, I must open the port 80. You agree? I must open the port 80. Basically, people from outside world, people from internet want to connect to my load balancer on port 80. So I want to open port 80 for my load balancer, obviously. That's it. Click on next. Here I can choose the target group. So select the option existing target group. Then automatically the TGWP will come here. That's it. All settings would automatically pop up from the target group settings that you have specified. You cannot even change them because they automatically get popped up from the target group. Next, register targets. Automatically the target would also get registered because you already added two machines into your target group. Those machines will automatically get added to your load balancer. Then review, click on review button, then click on create button. Your load balancer is getting created now. That's it, your load balancer is created. It is being provisioned. It wouldn't take much time. I think hardly few seconds is what it takes to create the load balancer. And immediately I would also get a DNS name for the load balancer. I told you AWS does not show you the IP address of the load balancer printed here. Like your EC2 machine, in your EC2 machine you get a public IP, and that is printed in the console itself. But in case of load balancer, what AWS would ask you is, do not, if you are pointing your website to the load balancer, point the website to this name. Do not point the website to the IP address of the load balancer. Actually, there is a reason for that. It's something AWS internally manages. For example, the IP address of the load balancer can change depending on the situation. AWS may want to change the IP address of the load balancer when the load is coming, growing, when the load is less, depending on uh, different scenarios. AWS will want to change the IP address of your load balancer. There is a situation for them. So what they would do is, they will give you a DNS name, then pointing this name to the correct IP address, they will take care. And what they will ask you is, point your website to this name. Whatever IP address this name is pointing to, your website will also point to. That is the change you need to do in your authority name service. So you already have a DNS system. എടി നെറ്റ് വർക്ക് ചെയ്യണല്ല, അത് റീസ്റ്റാർട്ട് ആയെന്നില്ലല്ലോ. ഏ നീ ഒന്ന് ഓഫ് ആക്കിട്ട് ഓണാക്കി. Hey
Yeah, are you there?
guys, I'm sorry, actually, I again got some connection issues. I hope you can hear me now.
Yes.
Let me know if
Yes,
my voice
can
is
hear you.
breaking or anything. Now I am connected through my mobile hotspot. So let me know if you face any lag in the screen or problem with my voice. Yeah. So yeah, what I was trying to say is what AWS give you is a DNS name. They won't give you an IP address. What you generally do when you create EC2 machine, you get an IP. So in the DNS system, you will add an a record point basil.com or your website to the IP. That's what you do. In case of load balancers, if you want to point your website to a load balancer, you will not get an IP where you want to point to. Instead, what AWS would give you is just a name. They won't give any IP. All they give is a name. Why they are giving name? Actually, that is some internal purpose of AWS. The reason why they are giving name is they want the IP address of the load balancer to be dynamic. Sometime they would want to change the IP address of the load balancer depending on many situations, depending on the traffic, depending on right the network issues. There are many reasons. Some internal reason of AWS, they want to make sure that sometime they want to change the IP address of the load balancer. So due to that reason, they will not give you this IP, they will give you a name. They will say, this name is a permanent name. You can point your website to this name, and this name would be pointing to the right IP that AWS will take care. Right? All you need to do is point your website to this name. This name will automatically point to the correct IP. Even if the IP address changes, AWS will take care of pointing this name to the correct IP because the DNS of this name is something AWS has control over. So what you would do is you would point your website to this name instead of adding a record pointing to the IP. So in your DNS system, Route 53 or whoever is taking care of your authoritative name service, you would point your website, let's say www.basil.com, you would point to this particular name. If you want to point a website to a name, such kind of DNS records are called CNAME record. I will tell you how the CNAME record works. Let's say you go into your authoritative name server, maybe Route 53, then you pointed basil.com, CNAME, then the name of this particular road balancer, whatever name that you have got here. Now people from internet browse for www.basil.com. The request will go to your authoritative name server. It will ask the authoritative name server, what is the IP address of www.basil.com? The authoritative name server would say, find out the IP address of this DNS name. That's what the authoritative name server know. It does not know the IP address of basil.com. So as a response, the authoritative name server would ask you, go ahead and find out the IP address of this name. Then you will reach to the respective name surveys. Maybe these are the authoritative name surveys of this particular name, the load balancer name. They will give you the correct IP address of the load balancer. Then you will connect to the correct IP address of load balancer. Then there are backend machines. Through the backend machine, you would be served. This is how the whole system would work. If you want to point your website to the load balancer, you should add a CNAME record in your authoritative name server to point your website into whatever name AWS would give you when you create the load balancer. In my case, I don't have a website name. What I would do is I would use this particular name for testing. I can browse for this name in my browser. Then automatically what will happen? My browser in my Mac, it will try to connect to the load balancer, which is in Mumbai. And behind the load balancer, I already have added two machines. One is my private machine. One is my public machine. In my public machine, I already have set up Apache. So only this machine is healthy. because I did not install Apache in this machine. So whenever the load balancer will perform health check, it will find that this machine is not responding, only this machine is responding. Then my request which I am sending from a browser would be redirected to this particular machine, and I will get the pages from this machine. So if I browse for this load balancer URL, I am expecting the same Apache page which you found inside this machine. Let's see. It might take a little bit of time. The reason is this name is dynamically generated. So some DNS change need to take place when they generate this name, which would take some time to take effect. So it will work. Maybe I need to wait for some time. This is the load balancer name. If I browse for that name, I will hit the load balancer. Then load balancer will try to connect to one of the healthy machine in the backend. There's only one healthy machine, which is my machine in the public subnet where I already installed Apache. From that machine, it will fetch the Apache page, and uh, it would be printed in my browser. Okay, it's working. I got the page displayed in my browser. Give me 1 second. Right, I will come back in a minute.
I can't hear you.
Hey guys, I'm sorry. Yeah, so I got the web page, right? I browsed the load balancer URL. So what happened? From my Mac, I browsed for the load balancer URL. So my browser connected to the load balancer. Load balancer sent the request to one of the backend machine, whichever is healthy. Got the page from there, and the page is served to me. And at any point of time, you can go to your load balancer, go to the target group here, then click on the targets. You can actually see which machine is healthy, which machine is not healthy. Right now there is only one machine that is marked as healthy, the other machine is marked as unhealthy. You know the reason. Actually, I did not install Apache in that machine, so whenever my load balancer tried to connect to that machine, it will not respond. Then automatically the load balancer will mark that machine as unhealthy. If this machine was also healthy, what will happen? If I refresh this web page here, maybe the next request will go to the other second machine, and this page will come from the second machine. So I don't really care from which machine the page is coming. For me, the page is coming. That's what I care about. The your WordPress website or your web application is up and available to your customers always, no matter if one of the backend machine is down. If both machines are up, then I will get the page from any machine. Otherwise, I would get the page from the healthy machine. That's what the load balancer will internally take care. Can the load balancer connect to the private subnet of the VPC? Yes, the load balancer can connect to the private subnet of the VPC also. So basically, the load balancer itself is created in the same VPC, but in public subnet. But yeah, it can connect to the private subnets of the VPC. Yes, and the load balancer does have a public IP. Okay, the load balancer actually has a public IP. How you will find out the public IP of load balancer? Is there any way you can find out the public IP of your load balancer at this point of time?
We can ping the
You can pick,
host.
or you can run the dig command, right? So you already have the name of your load balancer. This is the name of your load balancer. You can run a ns lookup command, ns lookup, or right, dig, or whatever command. Ns lookup, then the name of the load balancer. You will get the IP address of the load. Actually, there are two IP addresses, right? At any point of time, you can use the ns lookup or dig or ping command to find out which IP address the name is pointing at this point of time. But maybe tomorrow when you do that, maybe you will find a different IP. So at any point of time, load balancer does have a public IP. Because it is facing the internet, it must have a public IP. People are connecting from internet to the load balancer.
Yeah, Basil,
Yeah,
that load balancer is sitting inside the VPC or outside the VPC?
it's inside the actually it has to be inside the VPC, I believe.
Okay.
But yeah, I mean, on the configuration part, uh, it has a VPC, it has a private IP. Load balancer does has
Okay.
a private IP using which it can connect to the all machines in the VPC. And all load balancer should be in a single VPC. Load balancer cannot spread across multiple VPCs. Okay, so our next topic is auto scaling, which we will start after a short break of 5 minutes. Take a short break of 5 minutes and we will start with auto scaling. Yeah, okay. So what is meant by auto scaling? It's basically, think about the situation. You have a website, a web application that is getting a lot of traffic. The traffic is unpredictable. Think about Flipkart. They have a big billion day, right? Or right? Think about any website and there is a campaign going on in that particular website. So they are expecting a lot of traffic coming to the website on that particular day. They need extra machine to be added in their infrastructure on that particular day. They need additional machine to be installed in the infrastructure, because the normal machine cannot handle that huge traffic. Right now there are 100 machines. The 100 machine will not be able to handle the huge traffic coming on that particular day. Maybe on that particular day you need some 500 machines. Sometimes the traffic is predictable because you scheduled a date for the campaign. Then it's okay, you can plan for that date. Sometimes you cannot even predict it. Sometimes the traffic can grow high, traffic can come back to normal. It can be sometimes unpredictable also how much traffic is coming to your website. So it is not possible for you to really watch your infrastructure. Then whenever you find that traffic is coming, then immediately add the machine. Whenever you find that the traffic is back to normal, you want to remove the machine so that you don't need to pay for the extra charges. It's not feasible if you have to do it manually. It should be done through an automated process whenever the traffic is coming. Or maybe, I mean, not just the traffic, sometimes there are lots of files that need to be processed, or sometimes there are lot of data that need to be written into a database. So depending on the heavy usage of the application, you can decide depending on some monitoring factors. The factor can be how many people are browsing right now, what is the CPU load on existing machines, what is the memory usage on the existing machines, what are the number of files in a particular application which need to be processed, how many files are there to process. So depending on many scenarios that you can monitor yourself, you want some machine to be automatically created or deleted from your infrastructure. So based on demand, your infrastructure will self-serve. When the infrastructure believe that it need to create additional machine, it will create the machine itself. When it believe that things are back to normal, now we can delete machines, it will delete the machine itself without any human intervention. So you need to pay, you already know the policy, AWS payment policy, you need to pay only when you use them. So let's say you have auto scaling enabled in your infrastructure, and in general cases you will run some 100 machines always throughout the month. You would run some 100 machines, some additional 400 machines you would create them whenever you need to, then you will delete them once you're done with using. Maybe in a month you are going to use hardly 10 hours or 15 hours, you need to pay only for 15 hours, no need to pay for the entire month. So AWS provides this flexibility, and AWS encourage their customers by providing auto scaling as a service to use the machine whenever they need and do not use the machine whenever they don't need, which would save a lot of money to the AWS customers. You can save a lot of your money if you have auto scaling, and also make sure that your infrastructure is handling the traffic coming to it. So let's see how the auto scaling works in AWS. What you would do is, so think about your WordPress website. Again, most of the time you would be taking the examples of web applications. So take your WordPress website or take the web application your company have as an example, and assume maybe you have a load balancer. Load balancer may not be mandatory, but assume you have a load balancer, elastic load balancer, which get the traffic from public on your website basil.com, and you have two backend machines always connected to the load balancer, and this both machine look alike, right? I mean, what you, this machine is clone of this machine. You create, set up one machine, install WordPress or do whatever inside this machine, do the deployment, then take an AMI of this machine. Using this AMI you would create the other machine. So both machines are identical, but sometimes the traffic is very heavy, or sometimes the CPU load on this machine is getting very high, then automatically you want more machine to be added, maybe from the same AMI. from the same AMI you want more machine to be created, and they will also get attached to the load balancer. So this time load balancer has connected to 4 machines instead of 2 machines. So automatically, based on the CPU load on the existing machine, the load balancer will scale up. I mean, load balancer will get more machine connected to it. And when the traffic is back to normal, when you believe that now the CPU load is normal on all these machines, you can delete one machine from this group. Then again, after some time, you can perform another checks looking at the CPU load. If it is still very normal, you can delete the other machine also. Then you are back to the normal circumstances, only 2 machines behind the load balancer. So you get the flexibility to add the machines whenever you need to, or delete the machine whenever you don't want. Let's take a look. So this machine that are going to be added up or deleted will be part of a auto scaling group. First thing that you do is you would create a auto scaling group. You can mention minimum I need 2 machine inside this auto scaling group. That you can mention like this. I need minimum of 2 machine in the auto scaling group. Then monitor the CPU load in this group. That means it will monitor the CPU load of all the machine inside this group. If the CPU load is, let's say it is more than 80%, that means the CPU is very high, load is very high, then automatically add another machine from a particular configuration that you have defined. This is called the launch configuration that you already would define. Launch configuration is nothing but from which AMI you want to create the machine, what is the instance type, what key pair should be used, what is the security group, what is the whatever details that you would specify when you create launch a new machine. That's what you call the launch configuration. So using this launch configuration, a new machine will be created. Then again, after 5 minutes or maybe, it will again check the CPU load on the entire group. If the average CPU load on the entire group is still more than 80%, then one more machine will get added from this launch configuration. So like that, you perform some monitoring, maybe CPU monitoring, memory monitoring. Sometimes it's up to you to define what kind of monitoring you want to do. And you define one more monitoring to scale down your machines. This is the second monitoring. It will check if the CPU load is less than 50%. This is another check you are performing. So let's say at some point of time, everything came back to normal. Your infrastructure is not getting too much load. And the load has reduced, the traffic has reduced. Now the CPU load on all the machine has come down. There is another check which keep on checking if the average CPU usage is less than 50%. If it is less than 50%, one machine will be deleted from this group. This check also performed every 5 minutes. So after 5 minutes, it will again check what is the average CPU load now. If it is still less than 50%, it will delete one more machine. So you can specify a minimum limit and maximum. You can specify 2 machines should be there, minimum 2 machines, maximum 10 machines. You can specify like this. In that case, between 2 and 10, the machines would scale up or scale down based on a monitoring criteria. That's what auto scaling is. So first you define a launch configuration. Basically, you specify from which AMI the machine will be launched, from which key pair will be used, the security group which will be used, right? The instance type, the storage, EBS volume, all these things you would mention in the launch configuration. So whenever a new machine get added to this group, machines uses this launch configuration. So basically this AMI that you use in the launch configuration would be nothing but the AMI of your WordPress machine, right? If you want all machine look alike, what you would actually do is this AMI should be taken from one of your WordPress machine, and same AMI would be used whenever it want to create a new machine. Then you also have this option, attach this group, the auto scaling group, to a load balancer. then automatically every machine which is getting launched in the auto scaling group or getting removed from the group will automatically be attached with the load balancer. So the load balancer will have the machines running in the backend, and the auto scaling which you have performed or set up would take care of deleting the machine from the load balancer or adding new machine to the load balancer. You can optionally attach this entire auto scaling group into a load balancer. It is a optional settings that you want to do. Let's say in case of WordPress website, you have a web application basil.com. In that case, a load balancer is mandatory. You can see you want basil.com to be pointing to the load balancer. So attaching your auto scaling group to the load balancer is important, but there can be situations where you don't need a load balancer. For example, think about this situation. You have a database. To this database, people keep on uploading some files, right? Keep on uploading a number of files into this database. And what your EC2 machine does is, there are some software installed in this EC2 machine. This software will connect to this database. It will find if there are any new file coming to the database. It will take that file, then process the file, do something. And that's what all these machines are doing. So what if you put all these machines in a group? Then you are performing a monitoring. You are monitoring, instead of CPU, you are monitoring the number of files in the database. If there are 20 files in the database, then 3 machines are enough to process the 20 files. But if there are more than 20 files, then probably you want to add additional machines into this group. So as soon as new machines get created, they will connect to this central database, get the file, process them. So the file will be processed very quickly if you have more machines in the group. And when it's back to normal, let's say now the number of files is less than 20, then again a machine will be terminated from the group. Like this you can perform. So in this case, you find that you don't need any load balancer. Load balancer is not required in this particular use case. But if it is a website that, right, you are running Apache inside a machine, then you want all the machine to be connected to the load balancer automatically. In that case, you can connect your auto scaling group, the entire machines, into a load balancer. Up to you to choose depending on your requirement. So first thing I'm going to do is, I am creating a launch configuration. Basically, I want to tell whenever a new machine is getting added to the auto scaling group, what are the settings for the machine? The AMI ID, instance setting, instance type, EBS volumes, security group, etc. So under the auto scaling, you would find 3 options. This is where you can create launch configuration. This is where you can create auto scaling group. So first I will create a launch configuration. Click on launch configuration. What happened? Some problem. So it's okay. I will go ahead and create an auto scaling group. It will ask me to create a launch configuration first. So click on create auto scaling group. Then first it will ask you, first you create a launch configuration. So let's go ahead and create a launch configuration. Click on create launch configuration button. It will ask you select your AMI. So general cases, you can go to your my AMIs page and select your WordPress AMI. Got it, right? So most of the time it would be using a custom AMI you want to launch your machines, which is nothing but your WordPress AMI. The AMI taken from a working WordPress machine, the same AMI you would use whenever you want to launch a new machine in auto scaling group. So in generally, this is going to be your AMI that you are going to use. So maybe let me use that, right? I have a WordPress AMI. I want any new machine getting added to the auto scaling group, I want it to be created from this AMI. Then what would be the instance type? Any new machine that is going to be launching in auto scaling group, what is the instance type? The same details, whatever details you would specify, right? Give it some name for the launch configuration WordPress, IAM role, forget it. We are going to talk about it later. Under the advanced, let's forget it. Next, add storage, 8 GB. The same thing. By default, port A22 is open. If you want port 80 to be open on any machine, let's say it's the WordPress machine that you're going to work on. In that case, they should be listening on port 80. So you need to open port 80 in the security group. That's it. Click on create launch configuration. And I think I can select the VPC also here. No. My storage security groups. I think I don't need to specify the VPC here. Right. No need to specify the VPC. Just create the launch configuration. It will ask you to choose your key pair. Yeah, same thing. December 14. Yeah, I created a launch configuration. Now I can create a auto scaling group. I am automatically redirected to the create auto scaling group page. I need to specify some name. Auto scaling WordPress. Any name I can give. Start with one machine. Create one machine in the group. Create one machine. Start with one machine. Here I can select the VPC for my auto scaling group. That means any machine that are going to be created, which VPC the machine are going to be in. So I can choose only one VPC. Subnet I can choose maybe all the subnets, whatever subnet I have for this VPC I can choose. Okay. And no public IP would be assigned. The default subnet settings does not enable public IP on my instances. Maybe I don't want that. There's an option actually. If you go to VPC, if you go to your subnets, select your public subnet, select subnet action, click on modify auto assign IP settings, check this enable public IP box. Then next time when you launch a new EC2 machine, by default, the public IP option would be enable any machine that you create in the public. Did I select private or public? It should be public. I want, okay. It should be the public machine for which I want the public IP. Okay, fine. So now select your VPC once again. Select your subnets. No public IP will be assigned. I think this is coming from cache. Automatically now if I create a new machine is launched in the public subnet, the machine will automatically get a public IP because you change the subnet settings here. Fine. That's it. Advanced testings, let it be. If you want this security group to be attached with a load balancer, you can check this box. Then you can specify your target group. Okay, it's up to you. It's optional setting. So let's say I don't want it to be attached with a load balancer. I can uncheck this. Next. Okay, now I want to add the scaling policies. I have two options. Keep this group at its original size. Maybe that's not what I want. I want this group to be increasing in size or decreasing in size based on the demand, based on some monitoring criteria. If the CPU load is high, add additional machine. If the CPU load is low, remove additional machines. I need to add such scaling policy. So select this second option. Then over here you have the option, click on this button. You will get two policies. One is increase group size when you want to increase the group size. That means when you want to add more machine. Decrease the group size means when you want to remove the machine. So you can have two policies. One policy for increasing the size of the group, that means adding machines. Second policy for decreasing the size of the group, that means deleting machines from the group. So I'm going to define the policies here, monitoring and policies. So I am giving it the first policy is increase the group size. I can give it some name. Execute policy when I need to select an alarm. I will talk about this alarm later. We are going to learn about this alarm when we learn cloud watch service. Right now, don't worry about it. My intention is if the CPU load is more than 80% in my auto scaling group, I want to add one additional machine. That's what I want to do. So click on create, add new alarm. Over here, you can choose the condition. If the average CPU utilization is greater than or equal to 80% for at least one consecutive period of 5 minutes. So every 5 minutes, this monitoring will take place. If ever the CPU load is more than 80%, then this would be created as an alarm. So click on create alarm with this condition. That means if the average CPU utilization of the auto scaling group is more than 80%, take the action what you want to do. If this condition is met, what you want to do, you want to add one additional machine, or if you want you can add two additional machines together. I'm putting one additional machine when the CPU utilization is more than 80%. That is my rule. So if I have this rule, always remember whenever the CPU load is more than 80, it would add one additional machine. So this rule can only add machine. If you are adding a rule which will add machines, you should add another rule which will delete machine. Otherwise, think about it. The machine keep on getting added and they are never getting deleted. It's a bad situation, right? You are going to be charged a lot, right? So you want to make sure that when the CPU utilization is back to normal, you want to delete machine. So that is why you are adding one more policy for decreasing the group size. You can give it some name. I'm going to create a new alarm. Here I am mentioning if the average CPU utilization is less than or equal to 50%, click on create alarm. And if this alarm happened, if the CPU utilization is less than 50%, then I want to delete one machine. Maybe don't delete all machine together. I want to delete only one machine if the CPU utilization is less than 50%. These two rules I have. So both these rules, as you can see, the check will run every 300 seconds. That means every 5 minutes the check will run, and each time the check would run, it would decide what action it need to take, or does it need to take any action at all. It would decide, right? Click on next, configure notification. If you want any notification to be sent, let's say whenever a new machine is getting added to the group, you want yourself to be notified through email, you can add such kind of notification, which is optional. Click on next, configure tag, that's also optional. Click on review, then click on create auto scaling group. One or more security group configured in the launch configuration are not linked. Okay, okay. Security groups configured in the launch configuration. Okay, basically the reason is I selected a security group when I defined the launch configuration, right? That security group was actually created associated with a different VPC than my auto scaling group. So what I am going to do is I would change my VPC to the default one. Instead of Jan2, I am going to use the default VPC this time. Sorry about that. Yeah. Otherwise, what I can do, I can edit my launch configuration or create a new launch configuration and select a different security group. That's also fine. In my case, I'm directly modifying my auto scaling group and changing my VPC. That's it. Now you click on review, then click on create auto scaling group. Your auto scaling group is created, and maybe you may have noticed I did not mention the minimum is 1, maximum is 1. You mentioned actually maximum I want maybe 10. This is something, yeah. You can edit, click on edit button on the auto scaling group. There are some settings. What are the minimum size of the group? One instance. Till where it can grow up to 10. So a minimum and maximum value you can mention. What it means is whatever auto scaling happens, maybe the CPU load is high, it would add extra machines. It will not add more than 10 machines. 10 is the maximum limit. So you can specify a hard limit, maximum and minimum. If the CPU load is less than 50%, it will keep on deleting the machine, but it will not delete the last machine. The minimum is 1. So you can specify a threshold between which it will scale up or down, not beyond this. So you can set a limit, minimum and maximum limits. So up to 10 machine this auto scaling group can have, not more than that. That's what I mean by maximum is equal to 10. So if you, since I had mentioned the minimum is 1 machine, then automatically you would find that one instance already launched. If you go into the instance page, you can actually see a new machine got launched along with when I created the auto scaling group, because I mentioned minimum is 1. This is the new machine which just got launched when I created the auto scaling group. The reason is nothing but I said minimum machine is 1. So now I have this auto scaling group and I have one machine. What if the CPU load is more than 80 on this machine? What will happen? If there's only single machine, and if the CPU load is more than 80% on that single machine, what will happen? There is a monitoring that is being taken place every 5 minutes. It check if the CPU load is greater than 80%. If it is greater than 80%, new machine will be added from the launch configuration. So in order to test this auto scaling is working or not, what you can do is you can log into this machine. You can manually run some command to stress the CPU and make the CPU usage more than 80. There are some command in Linux that you can run which will actually stress out the CPU. So you can search in Google stress CPU Linux or Ubuntu. You can search for, you will get some command which if you run it, it will increase the size of the CPU of the machine. My voice is not breaking still, right? Okay, so this command you can run.
No, it's fine.
I will send this command in chat. This command you can run inside your machine. So I'm going to do that. I'm going to log into the machine which is in the auto scaling group. But this is not a manual process. Basically, depending on the traffic. If it is a live website, whenever the traffic is growing, that can increase the CPU load on the machine. Right? So in my case, I don't have a way to test it. The only way I can test is I can manually stress the CPU in this machine and I can check if it is creating additional machine in my group. So I am manually stressing the CPU by running this particular command. Run this command. Then maybe let me log into the same machine from a different terminal. I will actually see that the CPU load is very high now. Run the command top. You can see this particular process that I have started, the particular command which I have run, the dd command, is taking 99.9% of the CPU. Actually, the CPU is being stressed out. So keep running this command. Do not stop this command. Keep running this command for 5 minutes. Why 5 minutes? Because it's every 5 minutes your monitoring is happening. So within 5 minutes, the monitoring will detect that the CPU load is average CPU load of the group is more than 80. Then a new machine will be automatically added to the group. You just wait. You run this command, wait for 5 minutes, then you will see a new instance created in this page. In the instance page, you can see a new machine is getting launched. It will keep on getting launched, right? Let's say on the other machine also you are running something. The CPU load is high on the other machine also. Whenever the average CPU load, so this time now you have two machines. Let's say right now I have only one machine, and now the load is more than 80% on this machine. Within 5 minutes, one more machine get added, and assume this machine also has high CPU load. Maybe this has 100 as the CPU load, this has maybe 70. So what is the average? Average is 100 plus 70, 170 by 2, 85. Still the load is more than 80. The average load is more than 80. Within next 5 minutes, one more machine will be launched. You got it, right? Now you cancel this command. Now you stop running this command by pressing Ctrl C. Then the CPU load will quickly come back to normal. Within 5 minutes, a machine will be deleted by the scale down policy that check if the CPU load is less than 50. It will delete one machine. So this way you can test if your auto scaling is working or not. Got it? So I will give you the assignment, then I will take your questions, right? This is like a mini project that you need to do. First thing I want you to do is create a VPC and 3 subnets, 1 private subnet and 2 public subnets. Both public subnet, one public subnet would be created in one availability zone, other public subnet would be created in other availability zone. Why? Assume you have a load balancer. You have 2 WordPress machine in the backend. Both are running in the same availability zone. If both machines are in same availability zone, do you have high availability actually? Assume there's a problem with that availability zone in AWS. Both machines will down simultaneously. So what you prefer to do is, if you have 2 machines, you would put both machine in different availability zones, so that in case if there is a problem with the availability zone and one machine is down, you still have the other machine running. So you got it, right? What I want you to do is create 3 subnets in a VPC. First create the VPC, then 3 subnets, 1 private and 2 public subnets, and 1 public subnet in one availability zone, the other public subnet in other availability zone. Then set up a WordPress machine in the public subnet. In one of the public subnet, you create one Windows server, create a new machine, EC2 machine, then set up WordPress in that machine, right? You need to install Apache, PHP, whatever. Set up the WordPress in that machine. Then create a load balancer in the same VPC, then add the WordPress machine. Is this the assignment? Or yeah. So create a load balancer in the same VPC, then add that WordPress machine behind the load balancer, your EC2 machine. Take the AMI of the WordPress machine. Use this AMI for the launch configuration. You need to use this AMI in the launch configuration for auto scaling. Now you create the auto scaling policy just like we did. If the CPU load is more than 80, create machine. If it is less than 50, delete a machine. Create the same kind of auto scaling policy based on the average CPU load. Then make sure that the machine, your auto scaling group that you have created, will be attached with your load balancer. Then do the testing. How you will test it? Maybe you can manually run this dd command to make sure that it is scaling up depending on your requirement. If the CPU average CPU load is more than 80%, whatever policy that you have defined, if it is 80%, make sure that additional machines are getting created based on these conditions that you had mentioned. So finish till here, till this part. Okay, and the MySQL database, create that MySQL database in a separate machine. Earlier in your example, in your WordPress assignment, you installed MySQL on the same machine as the WordPress machine. This time, install MySQL on a separate machine, which is in the private subnet. So your WordPress from the public subnet will connect to the private machine for the database access. So what you need to do is in the wp-config.php, instead of specifying the DB host as local host, you need to put the private IP of the database machine in the wp-config.php whenever you set up the WordPress. And let me know if you get any issues, write me an email, right? Okay. And our next class is at 7 a.m. IST on Saturday. That means you don't have class tomorrow at the regular time. Next class is after, now it is 11 p.m. right? So which means tomorrow 11 plus 8. So it's after 32 hours from now. Our next class would start 32 hours from now. The actual time is Saturday 7 a.m. IST. 7 a.m. IST Saturday. So remember, if you are from United States, it is Friday evening. We will start with Python programming. Saturday and Sunday we will cover Python programming, right? And Monday we will resume with AWS. We will continue with the AWS topics. Sunil, no. Next class is at Saturday 7 a.m. IST. That means exactly 32 hours from now. That's when our next class is.
Excuse me, sir.
Any questions?
Can I have a talk?
Yeah, you can log out.
No, I have a talk. I cannot able to take the Python programming because I will be at the work. So can you show me the record? Can you send me the recordings of the Python programming?
Sure. I will be uploading the
And
recording.
what about yeah? what about the assignments? Can you give me the assignments, so the previous assignments too, so I can try to do it and mail it to you? I already talked to you regarding this.
I will do it over this weekend.
Okay, thank you. Thank you so much.
No issues.
Yeah, Basil, Jay here. Hello.
Yes, Jay. Uh, I can hear you. Go
So,
ahead.
yeah, to configure this, we have used one image WP machine
Mm-hmm.
auto scaling. So later, if I want to update that image with that other image, can we do that? Because in real time, this websites will keep updating.
Whenever the website gets updated, you need to take a new image.
So I
And
mean, in the same auto scaling configuration, we have an option to update the image.
if you are doing it the image way, there is no option to update the image each
So
time.
what is the other way around?
There are other ways to do that, actually using some chef config management or using different tools. You can actually set up the machine when the machine is created. Apart from
So
creating from image, you can create the normal Ubuntu server, then set up the necessary software when the machine is created. So that you can do. When you create from image, actually there is no option. Whenever you there is a change in the software, you need to take a new image.
we are going to learn when we will start the DevOps training, the Puppet and all.
Yeah, we are going to learn that.
Okay. Oh, thank you.
Okay, yeah. So one more thing which I want to discuss. Let's think about this. You have a website which is globally okay. Now it's been 5 minutes, right? It's already 5 minutes. Now the auto scaling group would have created one more machine. Refresh this page. Yeah, you can see one additional machine got created here. Or if you go into the auto scaling group, you can actually see the current size is 2. It is little slow. Yeah, you will see that the auto scaling group. There you can see the current size, right? You would find that right now it is 2. Okay, so I am going to stop this, otherwise more machine can get created, or maybe I will just delete this auto scaling group. Make sure that you are deleting auto scaling group. Auto scaling group is not chargeable, but the machine which your auto scaling group will create are chargeable. There is no extra charge for auto scaling, but you need to pay for the machines that you are creating on a hourly basis. So now I have 2 instances, so I need to pay for 2 instances. So I'm going to delete this auto scaling group, which will automatically delete both machines. And load balancer is also costly, are chargeable. So once you are done with load balancer and tested it, delete the load balancers. Auto scaling, no extra charge, but you need to pay for the machines. Load balancer, there is extra charge. So delete the load balancer once you are done with your testing. Okay, so let me ask you one question. I have one website, basil.com, and I have lot of customers from different countries. I have customers from India and I have customers from Ireland also. From 2 countries, I have customers. So I will set up a infrastructure in Ireland, which would include elastic load balancers, backend machines, Maybe it would include some auto scaling. It would include a VPC. It would include multiple subnets. And I need an infrastructure in Ireland region. I need one infrastructure in Mumbai region. In both region, I have a load balancer. I have the elastic load balancers in both the regions to which I want to point my website to. So I want the basil.com to be load balanced across these places between Mumbai and Ireland. Or maybe what I want to do is, if people from India are browsing for elastic load for basil.com, they would be automatically sent to this elastic load balancer. If people from Ireland are browsing for basil.com, I want them to be redirected to this load balancer in Ireland. Or if this one is down, I want all people to be sent to Mumbai, whether they are browsing from Ireland or they are browsing from India or from any part of the world they are browsing. I want them to be sent to Mumbai, not balancer. How I can do this kind of balancing, clustering? Actually, Route 53 is the solution. We are going to talk about Route 53 in our next class. In the Route 53, you have the option to specify. Point the website to this particular load balancer. You can specify the load balancer name by adding a C name. If the people are requesting for the website are from Ireland, otherwise send them to this load balancer. You can specify such kind of DNS settings in your authoritative name server in Route 53. If Route 53 is your authoritative name server, you can specify such kind of settings. You can even specify some health checkings saying that point the website to this load balancer if the other load balancer is down. Basically, always point the website to the healthy load balancer if the other is unhealthy. So the Route 53 itself can perform the health check. It would perform health check on this load balancer. It will perform health check on this load balancer, and whichever load balancer is healthy, when people browse for your basil.com, they request the Route 53 for the IP address of basil.com. Route 53 will provide only the healthy machine's IP. Then you will connect to the healthy load balancer. This kind of global clustering also you can do if you have both Route 53 as well as the load balancer. So load balancer will make sure that within a region the machines are load balanced and health checks are performed. Route 53 will make sure that globally it is performed across multiple regions of AWS. This load balancing is, or the clustering is done. So we are going to talk about this in detail when we learn Route 53, which is going to be our next class, right? On Monday, not Saturday. It would be on Monday. The same time, regular time, we would be covering Route 53.